Welcome. In this video I'm going to show you how you can obtain Johnston-Berry-Mieke E with Python and my stikpetP library. This is an effect size measure that could be used with a goodness of fit test. So for example a Pearson chi-square goodness of fit test. I'm using a Python version 3.818. This is actually their scary looking formula, but you don't need to remember that because the stikpetP library has a function that will calculate it for you. There are actually two versions. One's for a chi-square test of goodness of fit and one for a likelihood ratio or a G test. It can actually be converted also to Cohen's W, and that's important because then you could use Cohen's W's rules of thumb for interpreting the effect size measure. Although others say you should let that depend on the field that you're using. To show you how this can be obtained, I'll need some example data, so I'll load in pandas as PD, and then I can use their CSV function to load in the general social survey data from 2012 adjusted for some example purposes. Now once this is loaded, I actually don't need all of its data, I just need one nominal field. So I'm going to be using the mar1 field, which is the marital status. To give you a quick impression, the value count showed that, for example, 79 people indicated to be separated. Now my library is available by downloading it or at least installing it directly from my GitHub account. So don't just use pip install stikpetP because that most likely will not work. I'm not sure if in this environment I've actually installed it, but we're going to find out soon enough. Yep, it installed, so that's great. We'll need for this function actually the chi-square test value. Now, if you use the TS Pearson goodness of fit, for example, but you can use any other test. I have functions for many of them. In the results, you will actually find the chi-square value, the minimum expected count, and also the sample size. So I can just run that, and I should be getting all three of those. Those will be the input for this function, the ESJBME. And I can just now feed it all the information, and that gives us the effect size measure. Now we can convert this to CohenW. I have a separate function ESConvert for that from JBME to CohenW. And it also needs the minimum expected count, but as a proportion, so divided by n. That's why we also needed that one. So the Cohen's W is actually 0.80. And then we can use the rules of thumb from CohenW, and in this case this could be classified as a large effect size. Very similar, if you do a G-test, then you can use the TSG goodness of fit test, for example, feed it that nominal field. Again, we get the test value, we get the minimum expected count, and then we can actually calculate JBME. And now we're actually indicating that it's a G-test by the additional parameter here. We can convert it again to CohenW and then use the qualification, and also that one will in the end show us that it was large. And you can see JBME is 0.18 while CohenW is actually 0.85. Alright, I hope this was helpful and thank you for watching.